Okay, this is the study session for the kinematics unit, or the acceleration unit as you may know it. Kinematics is just a fancy word for it. So, number one, a rock is dropped from the top of a tall building and takes 4 seconds to reach the ground. How tall is the building? Well, height is a measurement of distance. So, how tall is the building? I know I'm looking for distance. What is it that I know for sure? Well, I know time is equal to 4 seconds, and I know that it's in free fall. So I know the acceleration is negative 10 meters per second squared, and I know that since it was dropped, the initial velocity is 0. So I'm going to use d is equal to 1/2 at squared plus vit to solve this. Initial velocity is 0, so that goes away. So I'm left with d is equal to 1/2 times negative 10 times 4 squared, and I should get d is equal to negative 80. Alright, so negative 80 meters. And so what that means is that if it fell 80 meters, then the height would just be 80 meters. Or how tall is the building? It's 80 meters tall. Alright, on number 2, you've got to remember that if you have a graph of velocity and time, and it looks like this, if you're looking for average velocity, you got to remember back to our previous unit and remember average velocity is equal to distance divided by time. What you cannot do, absolutely cannot do, is just go 0, because this is 0 right here, and this is at 8 here. What you can't do is say, okay, 0 plus 8 divided by 2 is 4. And the reason you can't do that is that's the average velocity for this section, but it does not include this section. So we have to make sure to include that section. So what we have to remember is that we have to do the area under the curve. Okay, so the area under this curve here should be equal to the distance. And so I'm going to do this first bit first, so this little triangle here. And so that would be, a triangle is 1/2 base times height. So I should get 1/2 times 8 times 4, which would be 16. And then I'm going to do this bit next, from here to here. So that would be actually it's a square, or no, it's a rectangle, sorry. And that's just base times height. So that'd be 4 times 8, because it's 8 minus 4 seconds, and then it's at a velocity of 8 meters per second. So I would get 8 times 4 is 32. So my distance would be 32 plus 16, which would be 48, divided by 8, which is 6 meters per second. Okay? And then it says, what is the acceleration of the object during the first 4 seconds? Well, during this first 4 seconds, it goes from 0 to 8 meters per second. So my initial velocity is 0, my final velocity is 8, and 4 seconds went by. So I've got VI, VF, and T. So I'm going to use A is equal to VF minus VI over T to solve for acceleration. And when I do that, I get A is equal to 8 minus 0 over 4, which gives me A is equal to 2 meters per second. Alright, that's number 2. Alright, number 3. I don't have a ruler on me, so I'm going to have to show you number 3 in a future video that I will label. Alright, sorry I do not have a ruler at the house. Okay, so again, that'll come in a future video. Alright, number 4. A ruler is dropped from rest in a physics experiment to determine reaction time. A student being tested catches the ruler at 20 centimeter mark. What is the student's reaction time? So essentially what you need to know is that this ruler is dropped from right above the student's fingers, so when he catches it, the ruler fell a distance of negative 20 centimeters, or 0.2 meters. Okay, so that's the distance it fell. Now what other stuff do we know about this? Well, it's in free fall, so acceleration is equal to negative 10 meters per second squared. The ruler was dropped, so the initial velocity is 0, and I'm looking for time. So what formula has time in it that's got distance, acceleration, and initial velocity, where time is the only unknown, d is equal to 1/2 at squared plus vit. And since vi is 0, it goes away. So we're left with negative 0.2 meters. Sorry, that should be negative because it's falling down. Equals 1/2 times negative 10 times t squared. And so we solve for t squared, and we get negative 0.2 over negative 5 equals t squared, and we square root, and we square root, and we get 0.2 seconds. Okay, so the time would be equal to 0.2 seconds. Please notice how the negatives cancel out. That's important to remember. If you end up getting an unreal answer if you square root, check and make sure that something wasn't supposed to be negative. Alright, last one, number 5. This is a lengthy one, so I will do it a little bit at a time. There's 3 questions asked here. So it says a tennis ball cannon is shot straight upwards with a muzzle velocity of 60 meters per second. What is the speed of the tennis ball after 2 seconds? Where is the tennis ball after 8 seconds? And how high does it go? Alright, so what is its speed after 2 seconds? So, actually, first of all, we know that the muzzle velocity is 60 meters per second. So what that tells us is that the initial velocity is 60 meters per second. Okay. We know also that the acceleration is negative 10 meters per second squared because it's in free fall. And we know that well, that's really all we know at this point. For A, the question A, we know that the time is equal to 2 seconds. Okay, so what we're going to do is we're going to try to figure out what on A. Well, it says what's the speed after 2 seconds. So what that's saying is what is the final velocity or the final speed. So if I have VF that I'm looking for, T, A, and VI, which formula should I use to solve VF? I should use A is equal to VF minus VI over T. And so, if I solve for this, I get negative 10 equals VF minus 60 over 2, and I get negative 20. Multiply the 2 up, I get negative 20, VF minus 60, add 60 over, and I get 40 meters per second equals VF. Alright, for part B. For part B, it says, where is the tennis ball after 8 seconds? Well, on this one, what I've got to do is I've got to solve for distance. That's where is. If you ask where is something, you're asking for a positional relationship. So position is distance, so that's what I'm looking for. D is equal to 1/2 AT squared plus VIT. Now, I need to know if I have all this stuff, right? So I'm looking for D, so it's fine that I don't know that. Do I have A? Yes, it's negative 10 meters per second squared. Do I have T? Yes. In this case, it's not 2, it's 8 seconds. Do I have the initial velocity? Yes, it's 60 meters per second. So I'm going to plug this in. D is equal to 1/2 AT squared, or rather, I'm going to plug these numbers in. 1/2 times negative 10. Well, crap, I can't write negative 10. Negative 10 times 8 squared plus 60 times 8. I'm running out of room here. Plus 60 times 8. Okay, so if I multiply all this out, D is equal to 1/2 times negative 10 is negative 5 times 64 plus 60 times 8 is 480. And so if we do this bit, I should get D is equal to negative 320 plus 480. Alright, and then that would give me an answer of D is equal to 160 meters. Alright, now, last problem. Let me rewrite this real quick. VI was equal to 60 meters per second. Acceleration is going to be equal to negative 10 meters per second squared. And it asks how high does it go. Okay, so we need to make an assumption that at the highest point here, the velocity is what? The velocity is 0. So, what I need to do is figure out a formula that will work. If I know the final velocity, and the initial velocity and the acceleration, how can I solve for distance? So I showed you a formula today, which is on Thursday, that you could use if you want to. So I'm going to show you with the formula and without the formula. I'm going to do it without the formula first. So if I'm looking for distance, I would need the following. D is equal to 1/2 AT squared plus VIT. You should notice immediately that we're missing something critical, and that something is time. So I'm going to have to find it. So the only other formula that you could use really is A is equal to VF minus VI over T. So that would be negative 10 meters per second squared equals VF, which is 0, minus 60 over time. And if you solve for time, you should get time is equal to 6 seconds. Okay, now we can plug that back in over here. D is equal to 1/2 times negative 10 times 6 squared plus 60 times 6. And so we should get D is equal to, that should be negative 1/2, or sorry, negative 10, by the way, don't forget your negatives. Should be negative 5 times 36 plus 360. And that gives us D is equal to negative 180 plus 360, or D is equal to 180 meters. Alright, now, if this makes perfect sense to you and you just want to keep using that, that's fine. Stop here. But if you're interested, this is how you would solve the problem with that new formula. VF squared equals VI squared plus 2AD. We know the final velocity is 0. The initial velocity is 60 squared plus 2 times negative 10 times D. And we solve for it. We get negative 3600 equals negative 5. Here, I'll show you the steps so that you don't lose it. Alright, so we should get 0 is equal to 3600 plus negative 5d, and then we'll subtract 3600 over negative 3600 equals negative 5 d, and then we should divide by, why did I get negative 5? Sorry, this should be negative 20. Knew I messed up somewhere. Alright, so it should be negative 20 and then negative 20. So 2 times negative 10 is 20. My bad. So divide by negative 20, divide by negative 20, and we get 180 meters equals D, which you'll notice is the same as we had here. Okay, so I will post number 3 probably tomorrow whenever I actually have a ruler, but I hope this helped you out. If it didn't, feel free to contact me and let me know.